The story takes place about 130 years ago. At the time, there was a woman named Madame Curie in the country of Poland. One day, Madame Curie said, "I'm pretty bored, so maybe I'll tinker with some dangerous substances." In that manner, after skillfully obtaining and studying mysterious substances, Madame Curie made various remarkable discoveries. Firstly, in the world where we live, there is space, and within that space, there are various substances. And when we look at the inside of any substance on an incredibly small level, we find that they are made up of extremely tiny particles called atoms. However, when we zoom in even further to the core of these atoms, we find that they are made up of two types of extremely small spheres, which we can call tiny spheres A and B. Depending on how many of these tiny spheres of type A there are, the type of substance is determined, whether it's gold, iron, or perhaps something else entirely, like poop, for example. However, the dangerous substance that Madame Curie discovered was one where these tiny spheres were so tightly packed inside that they would lose balance and jump out. The tiny spheres jumping out from the core of the atoms in the substance are called radiation. Radiation usually refers to when spheres or something smaller than atoms forcefully jump out. So if, for instance, 4 spheres jump out like this, it's also a type of radiation. If tiny spheres like A or B jump out individually due to some cause, this is considered another type of radiation. And when this dangerous substance emitted radiation, it released an incredibly huge amount of energy that we don't normally experience in our daily lives. Mankind used this ridiculously enormous energy to generate electricity, create bombs, and so on. This ability of substances to emit radiation from within like this is called radioactivity. So substances with radioactivity are unstable because they're packed so tightly on the inside. Now, what kind of impact do these substances emitting radiation have on us? Let's take poop, for example. Imagine placing a substance with radioactivity next to this poop. Because the inside of the radioactive substance is packed too tightly, it emits tiny spheres as radiation, and the poop gets bombarded with this radiation. What happens next? Even poop is a substance, so there are atoms inside of it as well. When the radiation emitted from the radioactive substance mercilessly hits the atoms making up this poop, it messes up their arrangement. As a result, the poop's properties as a substance are fundamentally altered at the atomic level. And in some cases, due to excessive radiation exposure, the tiny spheres at the core of the poop's atoms may become too tightly packed, causing the poop itself to become radioactive. This means the poop could start emitting radiation. When humans are bombarded with this kind of annoying radiation, the intricately arranged atomic structure within the cells of the human body is mercilessly disrupted at a fundamental level. This can lead to diseases and other health issues, making it incredibly dangerous. In this way, Madame Curie, who was researching radiation, also died due to excessive exposure to radiation. But on the other hand, when radiation is accurately applied by humans, it can have positive effects on the human body at the atomic level. This can be utilized in radiation therapy to treat diseases. So while radiation possesses tremendous power and danger, radioactive substances do not infinitely emit radiation. The more radiation they emit, the more the structure of the tiny spheres at the core of the atoms changes. Eventually, the tightly packed interior stabilizes, leading to the loss of radioactivity. And so, the type of substance is determined by the structure of the tiny spheres inside the atoms. In other words, when a radioactive substance emits radiation, the structure of the tiny spheres in the atoms changes, causing it to transform into another substance. In this context, among the atoms of the same radioactive substance, the time it takes for half of them to emit radiation and transform into another substance is called the half-life. So what does this mean? Let's say there are 16 atoms of the same radioactive substance. If the half-life of these atoms is 1 day, then after 1 day, half of these atoms, which is 8, will emit radiation and transform into other atoms. So after another day passes, out of the remaining 8 that didn't change, 4 of them emit radiation again and transform into another substance. Then, the next day, another 2 atoms undergo the same process, and it keeps going like that, halving each time. The radioactive substances continue changing into different substances while emitting radiation. The half-life period serves as an indicator of the troublesome nature of radioactive substances. Unfortunately, some radioactive substances have a half-life of tens of thousands of years, making them incredibly dangerous for humanity. Furthermore, even after the half-life has passed and the radioactive substance has transformed into another substance, the new substance may still possess a more hazardous form of radiation. This adds to the despair surrounding radiation. And this concludes the explanation of radioactivity. See you next time.